Hello my dear students, welcome to chemistry classes. So in this class we are going to deal with the order of a reaction. The next important point is order of a reaction. So it is important. Why? Because on this one more question may come. So on the definition, what is the order of reaction? Or they may ask, so what is the order of reaction of a given equation or given chemical balanced equation? So then you have to calculate order of a reaction. First, let us understand what is the order of reaction. Okay, so here the order of reaction is the sum of powers of the concentration of the reactants in the rate law expression. This is rate law expression is called the order of reaction. Simply, order of reaction it is the sum of the powers. Sum means what? ಕೂಡಿಸೋದು ಹೌದಾ. ಸೊ ಪವರ್ಗಳನ್ನ ರೇಟ್ ಲಾ ಎಕ್ಸ್ಪ್ರೆಷನ್ ದಲ್ಲಿ ನಾವು ಏನು ರಿಯಾಕ್ಟೆಂಟ್ ಬರೀತೀವಲ್ಲ, ದ ಪವರ್ಸ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಅಂತ ಬರೀತೀವಿ ಗೊತ್ತಾ. ಸೊ ಆ ಎಕ್ಸ್ ಮತ್ತು ವೈ ಗಳನ್ನ ಸಮ್ ಮಾಡಿದ್ರೆ ದ ರಿಸಲ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆರ್ಡರ್ ಆಫ್ ಅ ರಿಯಾಕ್ಷನ್. ಸೊ ಇಟ್ ಈಸ್ ದಿ ಸಮ್ ಆಫ್ ಪವರ್ಸ್ ಆಫ್ ದಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಇನ್ ದಿ ರೇಟ್ ಲಾ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಫ್ ಅ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ is called as order of a reaction. For example, so I have written rate is equals to, this is the rate law expression for a particular reaction. Rate is equals to rate constant into concentration of A raised to X and concentration of B raised to Y. This is called as rate law. Here order of this reaction is equals to what? Order of reaction is equals to N. Generally it is denoted by N. N is equals to what? It is the sum of the powers, the concentration of reactant A raised to X plus B raised to Y. The sum of the powers is called as order of a reaction. Simply, it's very simple. Rate expression dalli ನಾವು ಏನು ಬರಿತೀವಲ್ಲ, concentration raised to X and Y ಅಂತ ಪವರ್ ಗಳನ್ನ ಬರಿತೀವಲ್ಲ, ಆ ಪವರ್ ಗಳನ್ನ ಸಮ್ ಮಾಡಬೇಕು, ಕೂಡಿಸಬೇಕು. ಸೊ ಕೂಡಿಸಿದಾಗ ಬರುವಂತ ಆನ್ಸರ್ ಏನು ಕರೀತೀವಿ ನಾವು? ಆರ್ಡರ್ ಆಫ್ ಅ ರಿಯಾಕ್ಷನ್ ಕರೀತೀವಿ. ಸೊ ಇಟ್ಸ್ ದ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಷನ್. So how to define this? It is the sum of powers of the concentration of reactants expressed in rate law expression. Okay, see here order of reaction can be what are the possible values of order of reaction? The order of reaction can be 0, it can be 1, it can be 2, it can be 3, or it can be more than 3. So please remember, it's important. Now order of reaction hengirbodu, it may be 0. If the value of n is equals to 0, the order is called as zero order reaction. Zero order reaction. If n is equals to 1, first order reaction. If n is equals to 2, second order reaction, third order reaction. So fourth order reaction, like higher order reactions are also possible. The value of order, it may be 0, it may be 1, it may be 2, it may be 3, or it may be more than 3, and also it may be a fraction. Even it may be a fraction. Fraction means what? The order of reaction may be 1 by 2, the order of reaction may be 3 by 2, 4 by 2. Sorry, 4 by 2 is not possible because 4 by 2 is nothing but 2 only. Okay, 5 by 2. So like that, the order of a reaction, it may be 0, it may be 1, 2, 3 like integers, or it may be a fraction. So these all the values are possible for a order of reaction. Please remember this. Next, a zero order reaction means the rate of a reaction is independent of concentration of reactant. See here, if rate is equals to K into A raised to 0. A raised to 0 means what? Order is 0. Anything raised to 0 is equals to what? 1. So according to mathematics, anything raised to 0 is equals to 1. Therefore, rate is equals to what? K. So the zero order reaction means the rate of a reaction is independent of concentration of reactant. Suppose the rate of order of reaction 0 idre adra meaning eno? Rate of reaction is independent of the concentration of reactant. Rate of reaction concentration of reactant ಮೇಲೆ depend ಇಲ್ಲ, because in this equation we cannot find any reactant term, concentration of reactant term. ಇಲ್ಲಿ reactant concentration term ಯಾವೂ ಇಲ್ಲ. ಸೊ ಈ ರೇಟು ರಿಯಾಕ್ಟೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇಲ್ಲ ಅಂದಂಗಾಯ್ತು. ಯಾವಾಗಿದು? ದಿಸ್ ಈಸ್ ಓನ್ಲಿ ಫಾರ್ ದಿ ಝೀರೋ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್. ನೆಕ್ಸ್ಟ್, see here, Based on this, we can calculate order of reaction. I have written two numerical problems here. Calculate the overall order of a reaction which has the rate expression. So these two are the rate expression. For them, we have to calculate order of reaction. First, let us calculate for this order of reaction n is equals to. So n is equals to what? X plus y. What is x here? X is 1 by 2 plus y is 3 by 2. How much it is? 1 plus 3 divided by 2. It is 2 only. So this is second order reaction. The overall order is 2 means what? This reaction is second order reaction. Therefore, second order reaction. So this is overall order. Overall order means what? It is the sum of the powers of all the reactants, concentration of all the reactants. If I ask what is the order of reaction, this reaction with respect to concentration of A, then it is the half order reaction with respect to concentration of B, and it is the 3 by 2 order of reaction with respect to concentration of B. Okay. So next for this, here the order is equals to x plus y. X is 3 by 2, y is minus 1. So how we can write? 3 by 2 minus 1. 3 minus 2 divided by 2, so minus 1 by 2. The order of reaction is minus half. Means what? The order of reaction may be 0, 1, 2, 3 or even a fraction, or it may be a positive value or it may be a negative value. The order of reaction, it may be positive or it may be negative. Please remember, this is important. So this is about order of reaction. We can sum up the order of reaction. So what is the exact meaning? We have learned we have understood what is the exact meaning, and let us see the order of a reaction as a summary. So order of reaction depends upon temperature and pressure. As temperature and pressure changes, order of reaction changes. Why? See here, as temperature and pressure changes, the concentration changes. As the concentration of reactant changes, their order also changes. So therefore, order of a reaction depends upon temperature and pressure. It is an experimental quantity. It is most important. Order of a reaction is an experimental quantity. Now within a experiment ಮಾಡಲಾರದೆ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ ಬರೋದೇ ಇಲ್ಲ, ಚಾನ್ಸೇ ಇಲ್ಲ. ಹೌದಾ? ಯಾಕಂತಂದ್ರೆ ನಾವು ರೇಟ್ ಲಾ ಯಾವ ಆಧಾರ ಮೇಲೆ ಬರೀತೀವಿ ನಾವು ಇದನ್ನ? The rate law is written on the basis of experimental results. ಹೌದಲ್ಲ? ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ಏನು ಬರೀತೀವಿ ನಾವು? ರೇಟ್ ಲಾ ನ ಬರೀತೀವಿ. ಈ ರೇಟ್ ಲಾ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಆರ್ಡರ್ ಬರೀತೀವಿ. So indirectly the order of a reaction is an experimental quantity. Without doing experiment, we cannot write order of a reaction for balanced chemical equation. ಯಾವುದೋ ಒಂದು ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ ಅದರ ಆರ್ಡರ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೆಯೋಕೆ ಬರೋದಿಲ್ಲ. ಯಾಕೆ ಬರೋದಿಲ್ಲ ಅಂತಂದ್ರೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದಾಗ ಮಾತ್ರ ನಮಗೆ ಏನು ಗೊತ್ತಾಗುತ್ತೆ, ಅದರ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಯಾವ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೇಲೆ ಎಷ್ಟು ಡಿಪೆಂಡ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಹೌದಾ? ಸೊ ದ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ, and the value can be 0, 1, 2, 3 or even a fraction, or it may be negative values. The order of a reaction, it can also have negative values, as this is our example. Okay, and one more important, it is applicable for both elementary and complex reactions. It is important. Order of reaction is applicable for both elementary and complex reaction. So first ನೋಡೋಣ, what is elementary reaction? ಇಲ್ಲಿ ಬರೆದಿದ್ದೀನಿ ಇದನ್ನ. Elementary reaction. So elementary reaction means what? A chemical reaction which takes place in only one step is called as elementary reaction. A reaction which takes place in only one step is called as elementary reaction. Then comes another word, complex reaction. Here it is elementary, and the second one is complex reaction. So what do you mean by complex reaction? A reaction which takes place takes place in more than one step is called as complex reaction. ಯಾವ ರಿಯಾಕ್ಷನ್ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸ್ಟೆಪ್ ಒಳಗಾಗುತ್ತೆ ಅದಕ್ಕೆ ಏನು ಕರಿತೀವಿ ನಾವು ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಕರಿತೀವಿ ಹೌದಾ. ಸೊ ಎಲಿಮೆಂಟರಿ ರಿಯಾಕ್ಷನ್ ಮೀನ್ಸ್ ವಾಟ್, ದ ರಿಯಾಕ್ಷನ್ which takes place in only one step is called as elementary reaction. A reaction which takes place in more than one step is called as complex reaction. And my question is, ಸಪೋಸ್ ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಇತ್ತು ಅಂತಂದ್ರೆ, ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸ್ಟೆಪ್ ಒಳಗೆ ಮುಗಿಯುತ್ತದೆ. ಈ ತರ ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಇದ್ದಾಗ ನಾವು ಯಾವ ರಿಯಾಕ್ಷನ್ ರಿಯಾಕ್ಟೆಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು ಹೌದಲ್ವಾ. ನಮ್ಗೆ ಏನ್ ಬೇಕು, ಟು ರೈಟ್ ರೇಟ್ ಲಾ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ರಿಯಾಕ್ಟೆಂಟ್. ನಮ್ಗೆ ಏನ್ ಬೇಕು, ರಿಯಾಕ್ಟೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬರೀಬೇಕು. ಸೊ ಇನ್ ದಟ್ ಕೇಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ರೇಟ್ ಡಿಟರ್ಮೈನಿಂಗ್ ಸ್ಟೆಪ್. ಅದ್ರಾಗ ಏನ್ ಸರ್ಚ್ ಮಾಡ್ಬೇಕು ನಾವು, ಇಫ್ ಅ ರಿಯಾಕ್ಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ 2 steps, first we have to identify which step is rate determining step. Please remember, in a complex reaction the slowest step is rate determining step. ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ನಲ್ಲಿ the slowest step is the rate determining step. It is called as RDS, not RDX, it is RDS, rate determining step. So ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ನಲ್ಲಿ, ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಮೀನ್ಸ್ ವಾಟ್, ದ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ which takes place in more than one step. ಸೊ ಸ್ಟೆಪ್ 1, ಸ್ಟೆಪ್ 2, ಸ್ಟೆಪ್ 3 ತರ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆ ತರ ರಿಯಾಕ್ಷನ್ ಆಗುವಾಗ ಯಾವ ಸ್ಟೆಪ್ ವೆರಿ ಮಚ್ ಸ್ಲೋ ಇರುತ್ತಲ್ಲ, ದಟ್ ಸ್ಲೋ ಸ್ಟೆಪ್ ಇಸ್ ಟೇಕನ್ ಆಸ್ ರೇಟ್ ಡಿಟರ್ಮೈನಿಂಗ್ ಸ್ಟೆಪ್. ಆ ಸ್ಟೆಪ್ ಏನ್ ಕರಿತೀವಿ ನಾವು, ರೇಟ್ ಡಿಟರ್ಮೈನಿಂಗ್ ಸ್ಟೆಪ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಆಫ್ ದಿಸ್ ಸ್ಟೆಪ್. The concentration of reactants of this step determine the order of reaction. And one more important thing, slow step ಯಾವುದು ಇರುತ್ತಂದ್ರೆ, in a complex reaction a step in which the new bonds are forming or the old bonds are breaking, that will be slowest. ಯಾವುದೋ ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಇದ್ದಂತ ಬಾಂಡ್ಗಳು ಬ್ರೇಕ್ ಆಗಬೇಕಾದ್ರೆ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಮೋರ್ ಟೈಮ್. ಸೊ ರೇಟ್ ಅವಾಗ ಏನಾಗುತ್ತೆ, ನಮ್ಗೆ ಅದು ಸ್ಟೆಪ್ ಸ್ಲೋ ಆಗುತ್ತೆ. ಅಥವಾ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ನ್ಯೂ ಬಾಂಡ್ಸ್, ಹೊಸ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಬೇಕಾದ್ರೆ ಅದು ಏನಾಗುತ್ತೆ, ನಮ್ಗೆ ಸ್ಲೋ ಆಗುತ್ತೆ. ಸೊ ಇನ್ ಸ್ಲೋ ಸ್ಟೆಪ್ ಮೀನ್ಸ್ ವಾಟ್, ಅ ಸ್ಲೋ ಸ್ಟೆಪ್ ಇನ್ ವಿಚ್ in this step the old bonds are broken and new bonds are formed. That step will be our slowest step. That slowest step is called as rate determining step. Okay, our rate of order of reaction is applicable for elementary reaction and as well as for complex reaction. In complex reaction it is particularly applicable for slowest step, that is called as rate determining step. Okay, and the next one is, the next important concept is unit of rate constant. The unit of rate constant. So here the rate constant means what, this K is called as rate constant. So it has a vital role in this rate law. So let us define the unit for this rate constant. ಅದಕ್ಕೊಂದು ಯೂನಿಟ್ ಅನ್ನು ಕೊಡೋಣ, rate constant ಗೆ ಒಂದು ಯೂನಿಟ್ ಅನ್ನು ಕೊಡೋಣ. So let us consider a nth order reaction. So let us consider one reaction that the order of that reaction is nth order. So A moles of A gives product. Because we don't have any business with this product, we are considering only concentration of reactant. So I have taken like this. For this the rate is given as, rate is equals to, how to write rate? Rate is equals to, according to this we have to write rate law, K into concentration of A raised to X, isn't it? We cannot take this as A. Why? Here X may or may not be equal to this A. So this is our rate law expression. Now I want to give unit for this rate constant. So now on rearrangement what happens, I want unit for this. K is equals to what, A raised to X comes this side, what happens, rate divided by concentration of A raised to X. So what is the rate, what is the unit of rate? The unit of rate of reaction is nothing but How we can write rate? Rate is nothing but concentration divided by time, isn't it? So initially we have discussed about rate of a chemical reaction. Rate of a chemical reaction means what? It is nothing but the change in the concentration of reactant or product with respect to time. And here 1 divided by, so this is nothing but concentration of A. Concentration of reactant means what? Concentration. Here I have taken nth order reaction. Here it is concentration raised to n. For nth order reaction, this will be n. This will be n. So now on what is the unit of this concentration? Okay, further simplification, what we are going to get? Concentration come to the numerator. What happens? Here concentration raised to 1 is here and divided by time into concentration raised to minus n divided by 1. So we can take directly like this only. How we can write? The bases are same. Here also concentration raised to 1 it is, concentration raised to minus 1. So how we can write? Concentration raised to 1 minus n divided by time. So what is the unit of concentration? The concentration is expressed in mole per liter. Mole per liter raised to 1 minus n divided by time is expressed in seconds. So this is the unit of rate constant. By using this expression, we can derive rate constant of any order reaction. Zero order reaction, first order reaction, second order reaction. Like we can calculate the unit of any order reaction by using this equation. Okay, so let us see how we can write. This side I will write by using this we can write the rate unit of rate constant for any order reaction. First let us take for zero order reaction. So here first one for zero order reaction. Zero order reaction. What we are going to write? We are writing unit of rate constant of zero order reaction. So here K is equals to, sorry, for zero order reaction n is equals to 0. K is equals to mole per liter raised to 1 minus n is equals to what? 1 minus n is equals to 0. 1 minus 0 divided by second. Here 1 minus 0 is nothing but 1. The unit will be mole per liter per second. If it comes to numerator, it becomes per second. So this is the unit for zero order reaction. For first order reaction, for first order reaction n is equals to 1, isn't it? For the first order reaction n is equals to 1. K is equals to mole per liter raised to 1 minus 1 divided by second. 1 minus 1 means what? 0. 0 means what? Mole, anything raised to 0 is equals to 1. 1 divided by second is nothing but per second. So this is the rate constant of first order reaction. And third one, second order reaction. Second order reaction. For second order reaction n is equals to 2. Let's write K is equals to mole per liter raised to 1 minus 2 divided by S. S means what? Second. Here 1 minus 2 means what? Mole per liter raised to minus 1 divided by second. See here how to write this. This raised to minus 1 means what? It goes to denominator. If it goes to denominator, what happens here? Here, okay, directly you can take mole inverse, and here it is inverse of inverse is nothing but liter only. and this will be per second. Here the unit of rate constant for second order reaction is per mole liter per second. Per mole liter per second. For first order it is per second. For zero order it is mole per liter per second. So please remember these three values because these are very important. By using this, see here, just by seeing the unit we can directly guess the order of reaction, isn't it? So if unit of the reaction is mole per liter per second, definitely it is zero order reaction, isn't it? If the unit of rate constant is per second, it is first order reaction. If the unit of rate constant is per mole liter per second, it is second order reaction. So like this you can directly guess or you can directly take the order of reaction. Okay, so this is the order of reaction. I hope all of you understood this. Okay, thank you.